1324, it says the door has a weight of 200 pounds and a center of gravity G. Determine how far the door moves in 2 seconds. So we have to find this thing, and it says starting from rest, if a man pushes on it at C. So there's a point C where man pushes the door from with a horizontal force F, which is 30 pounds. Also find the vertical reactions at the roller A and B. So we have to find the distance the door has covered in 2 seconds, and also the vertical reactions at roller A and B. So we draw a kinetic body diagram. So in that we see that there is a reaction at A and B, and their distance is 6 feet each from the center of gravity, and this is the weight acting, which is 200, and this is the horizontal force, which is 3 feet from the ground, and you can see that it is total 12 feet, so this is 9 feet, and the center of gravity is 5 feet from the bottom, and the acceleration is in direction of the force applied. So we use the sum of forces in x direction. So we can see that we consider that the right direction is in positive, so it is 30, which is equal to the mass. So to find the mass, we divide 200 by 32.2 and we multiply with the acceleration, which is in the x direction. So we get the acceleration, which is 4.83 feet per second square. And then we do the same for y direction. We consider that the upward direction is positive, and for this the acceleration in y direction is 0, because as you can see, when we push, there is a force applied on the door, there is no movement vertically, so which means that the acceleration is 0, so which makes this equation of equilibrium. So the upward and the downward forces are balanced. So Na plus Nb minus 200, which is the weight acting downwards, is equal to 0. So this is our one equation, and then we find the moment about point A, which will be equal to the moment of inertia. So we find the moment at A, which is Nb multiplied by 12, which is the horizontal distance of B from point A, and as B is acting vertically, so we find the horizontal distance, which is 12, and for same for G, which is acting in a vertical direction, so we find the horizontal distance. And then for force over here, it is in horizontal direction, so we find the vertical direction, which is 9, and we multiply with the force. And for anti-clockwise or counterclockwise, it is considered positive, and for clockwise it is considered negative, so we put negative with 200 is equal to the moment of inertia, which is mass multiplied by acceleration multiplied by the distance. So as you can see that inertia is in horizontal direction, so we multiply it with the vertical distance, which is 7. So by doing the calculation, we find Nb, which is 95, and then we put it in the previous equation, find Na, which is 105, and then we use the displacement equation, which is S is equal to initial displacement plus the initial velocity multiplied by time plus 1/2 acceleration multiplied by time square. As the initial velocity is 0, so that terms become 0, and there is no initial displacement, so that's also 0. So we put in the values for acceleration and time, and we get 9.66 feet. And also it is direction is towards right, and for normal forces it's 105 for A and 95 for B, and both of them are in the vertically upward direction.